Now that we've finished our exponent rules, we are going to expand upon this and work with some polynomials. And the exponent rules are still going to apply when we're working with polynomials. So a bit of vocabulary to review, which we did review at the beginning of the semester, but I just want to make sure that we know for sure what we're talking about. A term is just the multiplication and or division of numbers and or variables. So for example, we could have some terms that look like this. So this is an example. We could have, for example, 3x squared y to the 5. So that's multiplication of a number, the 3, with variables, the x, which is squared, and the y, which is the exponent of 5. We could just have a variable like x to the 4. That is just a variable, and that's considered a term. We could have just a number like 7. That is a term. We could have 3x squared y to the 4 divided by 2z. My 2's and my z's look similar, so that's why I always put a line through my z's. So that's multiplication and division of both numbers and variables. We could have something simple without exponents. We could have an 8x, and that also is a term. So those are all examples of terms, and when we're talking about terms, we can also talk about how many terms we have. Terms are actually separated by addition and subtraction signs. So terms are separated by addition and or subtraction signs. And for example, we could have 5x. That is a single term. And when we have a single term like that, that's referred to as a monomial. And I believe we discussed that earlier this semester. Monomial. We could have 3x squared, take away 5x. That has two terms because we have a term, a subtraction sign. So a term, the subtraction sign, and then a second term. That is called a binomial. And of course, subtracting really could be adding the opposite. So I could be adding negative 5x, binomial. And if we have three terms, we're going to have a trinomial. So for example, we could have 5 take away 8x plus 4x squared, for example. None of those can be collected because they're not like terms, and that's called a trinomial. Okay, and if you have any number of terms or more than 3 terms, but any number of terms is in general called a polynomial. Okay, so we would have also talked about the degree of a term. We did this in grade 9. The degree of the term is just the sum of the exponents on the variables in the term. Okay, the degree of a term is just the sum of the exponents on the variables in the term. So for example, we could have 5x to the 7, y to the 3. If I look at my variables, my variable x has an exponent of 7. My variable of y has an exponent of 3. If we were to add 7 and 3 together, that gives us 10, so this has a degree of 10. So that term has a degree of 10. We could have just x, and we know that when there's no exponent written, the exponent's assumed to be a 1, so that is degree 1. And if we have, let's say we had an 8, so this time I have no variable. That has no variable. It actually is a degree of 0. That's a degree 1. Just writing that in there. This is actually a degree of 0 because you technically could have an x to the exponent of 0. X to the exponent of 0, that really is equal to 1, and 8 times 1 is really back to 8. So that is a degree of 0. And let's say we had, 3x squared y to the 5, and then z. That together would be a degree of 2 plus 5 is 7, plus this one more would be degree 8. Degree 8 there. So that's really what we're looking at in terms of the degree of a term. Now when you get to the degree of a polynomial, you find the degree of every term in the polynomial, just like we found the degree of the term here, and then whichever one is biggest wins. Okay, so if we have an example of, let's say, a trinomial, I'll put a trinomial in here. If we had 3x squared minus 2x plus 5, we could look at the individual degrees of the terms. This term has a degree of 1. The second term has a degree, that's a degree of 2. The second term has a degree of 1, and this last term is a degree of 0. The 2 is the biggest, so overall this is degree 2. Okay, if I look at another one, let's say we had 5x to the 4, take away 2x to the 6 minus 3x. If we look at the individual terms, the first one is a degree 4, the second one is a degree 6, the third one is a degree 1, and overall 6 was the biggest number, so this is a degree of 6. So hopefully that makes sense. Just a few things to note, which I don't have a lot of room on this spot because I wrote really large. There's a few more details that we need to put in here. For example, when we're writing out polynomials, we usually write them in descending powers of x. So you'll notice this very first one here, I had the 2 as a degree, and then the 1, and then the 0. The second one, I did not write in descending powers of x. We normally would see that as negative 2x to the 6, and then we would have the plus 5x to the 4, so we're putting the highest degree first, and then the next highest degree term second, and so on until we get down to the lowest degree term. So we usually write our polynomials in descending powers of x. The number part of a polynomial is called the coefficient. So this x to the 6 has a coefficient of negative 2, the x to the 4 has a coefficient of 5, and the x has a coefficient of minus 3 or negative 3. So the word coefficient means the number in front of the variable part. And when we write them in these descending powers of x, the very first coefficient, that one is called the leading coefficient. Okay, so the leading coefficient is the very first coefficient of the highest degree term. All right, so I'm going to summarize those things down, and you should make sure that you also add them into your notes, even if it's on the next page or somewhere else in your notes. Just make sure it is written in there. Okay, so hopefully you've added that into your notes. Polynomials are usually written in descending powers of x. The number part of the term is called the coefficient. And when a polynomial is written in descending powers of x, the first coefficient is called the leading coefficient. And as you progress further in math, that leading coefficient tells us lots of things about the particular function that we're talking about. So that will come into play as time goes on. All right, expanding and simplifying. We did a bit of this at the beginning of the semester, so we're just going to review and use our exponent rules with this. What this is saying, the expand part means to multiply, the simplify means to collect like terms. If I look at this very first, like terms, first example here, we have 3x's multiplying the 5 take away 2x. So that 3x has to multiply everything inside this bracket here, which means the 3x is going to multiply the 5, and when it does, 3 times 5 gives us 15. We're going to end up with 15 x's. And then we have a 3x and a minus 2x that need to get multiplied. That's going to result in a minus. 3 times 2 is 6. X times x, we know should be x to the exponent of 2. Because x to the 1 times an x to the 1, keep the base the same, it's x, and then add the exponents. 1 plus 1 is 2. These are not like terms. I have an x term and then an x squared term. We cannot combine those. There's nothing here that we can put together. So we're actually finished with that question. If we move on to the next one, we have order of operations that follows along with this. This says 7, take away everything in this bracket. So if I'm taking everything away in the bracket, I'm taking away a 4x, and I'm going to take away the positive 1. So we can think of this as multiplying each term in here by -1, and when we do, we drop the brackets. We're going to have to do that multiplication before we do the 7 takeaway. All right, so we're going to get 7, and then I'm multiplying that -1 through. We get minus 4x. Minus a positive would be minus. 1 times 1 is 1. Now I do have like terms in this case. I'm going to write the minus 4x first. The coefficient of the x term includes the sign, and I'm doing that because I want to do descending powers. So I'm writing my x term first, the minus 4x, and then I have a plus 7 and a minus 1. So if I collect the plus 7 and the minus 1, so 7 take away 1 should be plus 6. So that is in its conventional form where we are writing that polynomial with descending powers of x. My leading coefficient then is the -4. Now this is a degree 1 polynomial, and we know degree 1s would be linear. So if this was y equals -4x plus 6, that will graph as a line. The previous example, if I were to write that in descending powers of x, I would have written that as a minus 6x squared and then a plus 15x. And by doing so, my degree is 2 overall for that polynomial. That degree of 2 is going to tell me that that is a quadratic relationship if it was y equals. It's going to graph as a U-shaped curve, and my leading coefficient is that -6. That's my a value. That tells me my direction of opening. So that's going to tell me this parabola opens down, has a vertical stretch by a factor of 6, and yeah, it's quadratic, it's U-shaped. Okay, so that's where that leading coefficient comes in. It tells us that direction of opening if it is degree 2. And the degree 2 tells us it's a U-shaped curve. All right, moving along. If you want to try the next example, you can put me on pause and then try the next one and then see what the solutions are. And likewise with part D, if you want to check that out, try it on your own first, go ahead and do that, and then you can check and see how you did. Okay, so for part C, when I expand it, I got the 3 and then the minus 8x plus 16 plus 3x minus 27x squared. If I collect like terms, I only have one x squared term. So my x squared term is the minus 27x. That's my leading coefficient is -27, so this parabola is opening down. Degree of 2 for this polynomial, so it is parabola. Minus 8x and a plus 3x combined to be the minus 5x. And then when I combine my constant terms, the plus 3 and the plus 16 go together to give me the plus 19 here. All right, try the next if you haven't done it, and then check. Okay, when I expanded, I got a 12x squared minus 20x, and then I took that -1 through the bracket, which changes all my signs. So I have a -x squared, a plus 6x, and a minus 1. And then I took the 2x and multiplied it through the brackets and got a plus 8x and a minus 2x squared. Now collecting like terms, I have 12x squareds, and then I have a minus 1x squared for 11x squared, 11x squared, and then take away another 2x squared. I ended up with my 9x squared here. My next term, my x terms, I've got minus 20x's. I add 6x's, that's minus 14x. Minus 14x, add 8x gives me minus 6x. And then I only had one constant term of minus 1, so that's giving me the minus 1. So again, it is quadratic because my degree is 2 overall for my polynomial. And if I were graphing this, this would be opening up, U-shaped curve opening up with a fairly skinny opening because my vertical stretch is a factor of 9.